Hello everyone, welcome to our next video session. So in this video let us try to understand what is Kubernetes API. So I think you already heard about what is this application programming interface, and we might already implemented using Java, .NET or any other programming languages. So implementation of the application programming interface. So why this API is important in the Kubernetes, why Kubernetes is related to the API, so why Kubernetes is API centric. These things we'll try to understand in this video. With that we'll just get started with the definition of API. API is application programming interface. So whatever the request we are sending to the application programming interface, so it will hit to the server, and we will get a response in terms of JSON format. So that we will send a request, maybe also in the JSON format we will be sending to the API. So in come to the Kubernetes part, why it is related to Kubernetes means, so whatever the request we are sending to the Kubernetes, it will be via API. So internally the API calls, it goes to the Kubernetes whenever if you want to create any kind of object, or it may be pod or deployment or any config map secrets if you are creating in Kubernetes. So everything it goes via application programming interface. We will see practically how the API is going to call in Kubernetes and what is this API behavior in Kubernetes. So, and we also try to understand what is REST and RESTful, and what is the difference between the REST and RESTful APIs. So why we are calling as a full, that is RESTful. So the differences, and we'll give some practical examples as well. So please do watch this video till the end. So everything in Kubernetes, it's an API, everything goes through the API, and API server in K8s. So whatever you are sending a request using a kubectl command, so using that kubectl command, the request it goes to the Kubernetes via API. So call API using a kubectl, and we will also try to understand what is JSON serialization and what is deserialization, comparison between the API and Kubernetes. So if you see this slide, so I am just comparing with Amazon warehouse and Kubernetes API. So why it's actually same. There is a similarities between when we are purchasing something in the website of Amazon or any website. So it is same as API server. Consider the client is sending a request to the API website, right? So when client is sending a request to the website, so what client he will do, he will for example, you are purchasing some charger, right? So you will just purchase it via website, right? The same thing in the Kubernetes server, you will, whenever you need some, for example, you need the config map or pod, you will send a request via API server. So here we are sending a request via website, but here we are sending a request via API server. So whenever you here in the Amazon, if you see, there is a warehouse, but here we have the Kubernetes API. So how in the Amazon warehouse we have the Amazon stuffs and third party stuffs, right? So same thing in the Kubernetes API, we have the objects and resources. So objects and resources are example pods, deployment, config maps, secrets, so services. Those things are Kubernetes objects, or we call it as a resources. And also we have in a Kubernetes third party stuffs. So we will be requesting those resources via API, like how we are requesting via in a website. So in Amazon website, we will be tracking, once you do the any order, we will be tracking the what is the status of that order, whether where it is, in which location it is coming, whether it is delivered or not. Those things we are tracking. The same way in the Kubernetes API as well. Once we order something, once we order the pod or deployment or config maps, we will not only the deployment, we will also observe that. So whether the pod is running or container is running, and config maps are created or not, that state will be observed. So this is how the relation between, like comparison between our purchasing website or Amazon websites and our Kubernetes API server. So whatever the request we are sending to the Kubernetes API, that will be via API server. So we all the calls, it goes via API server. Now the question is how, where we are calling an API in the Kubernetes. We are just using the kubectl command, right? So how API request it is going. So what Kubernetes it will do internally, it will convert your command, whatever you are typing that command, it converts into an as an API request. So I'll just open the command prompt quickly. So here if you see kubectl get pods, when you do the kubectl get pods and namespace, we are mentioning the prod namespace. So when you do like this, we are getting a response in terms of all the pod responses we are getting in a namespace of prod namespace. So internally what Kubernetes is doing, this request, whatever we are doing this request, it goes internally via an API. So it will call the API request, it goes and it will give the response. So now the question is how this request is going an API. So whenever you install your Kubernetes server or any, it may be the development server or in the production server, it will also create one config map. If you go to your the folder where we can see C folder and users folder, and here we have your own folder. If you go there, it will be created while creation of the Kubernetes, it also created a folder. That folder name is .kube, right? So in this .kube we will get a config file. So once we open this config file, so we'll see what it is there inside a config file. I'll just open with a notepad. So in this config file, the API version and the cluster details, the Kubernetes cluster details we have, and we also have the certificate authority and client certificate and client key data. So why this information is required, the certificates are required. So whenever we are calling any API server, right, so authentication and authorization is very important. So what Kubernetes will do, whenever you are calling this get pods, kubectl get pods of the namespace with prod namespace, internally it uses these certificates and it will call this server, this API server, which is already installed in your laptop, right? So it will call to this server via this certificates and you will get the response. So internally it will do. So just to understand how so can we call directly via this API? Via this API, can we call and can we get an response? Absolutely, yes, we can do that. So there is few commands we need to follow. What is the commands is kubectl proxy. We need to expose this port number inside in a local machine. So I'll just go here. This we'll just see after that what is this command it will do. So I'll just paste this here. Yeah, so starting to the serve, so this is serving your local host. This is nothing but the local host 127.0.0.1 and this is the port number it is serving. So now our local host, it is ready with the port number 9000. So what this line is doing, kubectl proxy, what it is doing means this command starts a local HTTP proxy server that lets you access the Kubernetes API server. It from the local host, it will allow you to access the Kubernetes API server securely without needing to manually handle the certificates or tokens. Without passing any tokens and certificates, it will allow you to access your Kubernetes server. That is why we are doing kubectl proxy -- port and 9000. So now this is listening. Now if you go to the there is one invoke web request, right? We are calling an API with the localhost 9000 and this is the command I am just using to invoke that API. So just to see whether this is working, get pods directly it is working. Now we will see by calling directly an API, web API request, so whether it works or not. So just open your PowerShell in PowerShell ISE. Just paste that command. So invoke web request. Okay, I think we have copied from PowerPoint, so some space it got added. So what I'll do, I'll just copy it to the notepad and we will just copy this invoke web request. I'll just add here and I'll just enter. So this is giving you all the response. Say for example how you are getting kubectl get pods, so hyphen namespace as prod namespace. So both are same. Here we are getting the 4 pods. When you do the kubectl get pods and namespaces prod namespace, this is exactly same as whatever we are invoking the web request. That means Kubernetes, when you are doing the get request of Kubernetes, right, kubectl using that command, that internally calls to the API. So API server, which we have seen in the config file, which is already created while installation of the Kubernetes. So this it will call this server internally when you do the kubectl command get post or get list or any creation, like we use the apply keyword, right, to create pods deployments. So it internally calls this API server. So here we are getting the response in the JSON format. So this is because this is an API call that we are calling as a RESTful. We call it as a RESTful API. So hence we are getting a responses here. So the response, if you see here, you will also get container information, everything. So whatever the pod is having the containers, every information you will get. So and volume information, those things as well. So coming to the pod initial first line of the your JSON response, here metadata, you see this demo deployment, and this is the pod name. This is the pod name, right? So this pod you are getting, which is there under the namespace. I'll go on the top here. So here if you see the kind, what is the kind information also we will get in the JSON. So kind is a which object it is. It's a pod list object, because we are invoking the web request localhost 9000, which is listening, we created as a proxy, and namespace which is there under this API, and v1, and under this namespace, what namespace? Prod namespace. So if you want to get the different pods of other namespaces, you can pass your custom namespace, whatever the namespace name, and whatever the pods are there under this namespace, we are just displaying all the content of the Kubernetes API server, right? So API version is the v1, and here this is the name. This is one of the pod we have, G40GLR. If you see whatever the response we got here, see 40GLR, that information we are getting from get pods, right? So that's how internally it calls, it invokes the web request only. So now coming to why we are calling this API as a RESTful API, and what is the difference between the REST and RESTful. So why we are calling it as a REST API means it is a representational state. Why we are calling it is a representational state? When you are accessing something into the server, say for example you are getting some employee details, right? So employee details, whatever it is there inside the database, you will get that response. So you will not get that actual response, but the response is in a JSON format. It is a representational state of the data which is already stored into the database. That's why we are calling it as a REST. So why the name as full RESTful, why we are calling it a RESTful? So typically what happens when APIs, it follow these rules. When any API, if it is following these kind of rules, we call it as a RESTful API instead of REST API. So for example, what are the principles here? We are considering stateless, no session, every request is independent. So whatever the API request was sending, everything is an independent. Client and server are separate. So you are just consuming an API server, is just consuming the data. So representational data you will get. So whatever it is there in the database that represents, you will get in a JSON format. So response should be cacheable if possible. So whenever you are getting an REST call, REST API call you are doing, the responses should be cacheable. We are caching, we can cache that response and request as well, and uniform interface. So we usually in RESTful, when you say the RESTful, the request we will do it in a get, post, put and delete, etc. So each request, for example, if you want to delete something by using your RESTful API, we won't use the post method there. Instead we use the delete method. So proper delete uniform interface we will use. Rather, sometimes what happens in a REST API, you make use only post for get, post and update update also you may use the post. So that is not a RESTful, that is only a REST. So if you say RESTful, each request, whatever the operation you are doing, for each operation the attributes used is a proper way, so then only it will be a RESTful. And resources via URL, things like users, order, representer, resources. Okay, you are in the URL itself we will mention what is the resource. For example, in our case, right, we already mentioned it's what is the resource we are, it's a namespace resource, and we are mentioning resource name and slash again pods resources we required in a proper way. So that's why it's a RESTful API. Representation usually it will be in a JSON format or XML format, how your resources are sent. So here in Kubernetes API we are sending in a JSON format, and in the response also we are getting a response. So now coming to what is serialization and deserialization. So when we are converting from any string to or object to string, when we are converting object to string, that we call it as a serialization. What is deserialization? Again, when you are converting from string to object back, so that we will call it as a deserialization. So whenever we are sending a request to the Kubernetes API, it will just we will just send an JSON format to the internally. It will go request in a JSON format, and you will get the response in a JSON format when we are directly calling an API. So that is an internal behavior of the Kubernetes that kubectl will take care based upon the whatever the config file got created, which we have already seen. So that's how this API it works. Okay, so this is how I just wanted to cover in this video. If you have any questions, feel free to post it in the comment section. Thanks for watching.